In this video, I introduce meta-learning via large language model in context tuning. Meta-learning learns to adapt large language models to a new task with only a few labeled examples. In context tuning recasts task adaptation and prediction as a simple sequence prediction problem by concasting in-context examples and the target input as a full prompt to a large language model. And then the large language model is meta-trained to learn from in-context examples. In-context tuning is understood as predicting the continuation of the concatenated input sequence as shown here. However, the accuracy of predictions is extremely sensitive to order of the in-context examples. For example, large language models suffer from the recency bias, which assigns a higher probability to labels that appear closer to the target input. One possible solution is to use meta-learning to directly fine-tune large language models for few-shot learning, so that the large language models learn to leverage the few-shot examples from multiple tasks to adapt to new tasks at a test time. Target agnostic large language models are meta-trained to perform few-shot in-context learning on a wide variety of training tasks. A large language model uses as input concatenation of a task instruction IT, task input output bias ST, and task input XT target, and then is fine-tuned to predict output YT target. The goal of large language models is to learn to use the in-context examples ST to predict the continuation YT target of the input sequence IT plus ST plus XT target. The few-shot in-context tuning objective L is defined as here, where T-train is a set of training tasks. Large language models are optimized by minimizing L on a set of training tasks T-train to adapt to a new task T-tilde at a test time, so that large language models use as input concatenation I T tilde plus S T tilde plus X tilde target and predict output Y T tilde target. No gradient update is performed during task adaptation. For more details, please check with these references. Thank you. Bye.